Okay, today I'll talk about some short channel effects that we've learned before. This is another review. You can see when the channel and when the device gets shorter, you can see there are some overlap caps here. If this means the total cap becomes bigger, and that means the transistor speed will get lower because the total cap becomes larger. The next thing we've learned was the subthreshold swing, which means the drain currents get 10 times bigger. The graph means that 10 times bigger than before, so that but you can see that it should be an ideal graph, but and you can see it here or here, it's not an ideally gets bigger. That means the subthreshold swing is getting bigger. And then we've learned about the punch through. The punch through was that the source and the the drain's junction boundary gets the junction boundary gets bigger, so that the currents gets through when the gate bias is not turned on. So to get this punch through solve, we've seen that we can dop some body more heavily, but this is not a good idea because when we dop the body hard, the junction leakage gets more bigger, so that the mobility of the carrier becomes much lower. So the next thing we thought was making a SOI. This is very useful, but it is a little bit expensive. Then we've learned about the VT roll-off. VT roll-off is not, it's a little bit different with the debul, the thing we'll learn later. The VT roll-off is because when the gates go shorter, you can see in the picture like this, the carriers comes up to the gate, so that becomes some gate leakage. Yes, you can see like this. And then we've learned about the debul, drain induced by lowering. You can see that this is slope. It means this slope means the differential of the potential energy. That means this is an electric field, and when you can see electric field is V over N. So when the M gets shorter, the electric field gets so bigger. So when we think that when the electric field gets bigger, the V should get bigger also. But in the contract electric field point, it doesn't get bigger, and so that we can see that it's the currents are not currents won't get bigger too. Yes, and then we've learned about the gate-induced drain leakage, which means the carriers gets into the gate, so that it at the drain part, the electrons get into the drain, so that the channel is not on and the gate is not on, but the current flows. And then we've learned about hot carrier effect. And so to solve this whole problem, we've learned the LDD, the lightly doped drain, like here, or the pocket impact to have some body doping place, like here with a halo junction. Yeah, and that's all.